been a while since we've done a live video. Figured we'd do one, just hang out for a little bit. I'm going to be here for a couple hours anyways. This is probably going to be a little bit slow, you guys, because I don't really have anything specifically planned to talk about. I thought we'd talk, there's obviously a billion topics, but I'm just pulling this up on my...
Can you guys hear me through the headphones? It's running hard for crowd now. Nice. Yeah, hear that. Can you guys hear me or no? Through here? Okay, 1 second.
This is kind of messed up. Let's see what we got here. 1 second, you guys. I'm struggling here. I've got to get the sound working again. My iPad swiped the headphones from this thing. So if this cuts out, just sit tight for a second. This is always a nightmare when these things don't work right. Cool. All right, this should work. If this doesn't work, I apologize. I just thought I'd throw this camera on for a little while and hang out. Well, so much for that lid. Somebody asked me to see the Okuma, so I'll show you guys real quick. Let me flatten out this control because I'm just going to spin the camera. I'm not actually going to grab it off the tripod. I've got the camera up real high so you guys can see what's going on. So that's the Okuma right there. And dude, it's so much bigger than I thought it was. I mean, just to give you guys some scale, I'm like 5'8" in tennis shoes, right? So I'm 5'7" and a little over 5'7" barefoot. And so it's a pretty big machine. It's no joke. And yeah, it's something else. It's crazy. Yeah, it is. It's something else. It's a pretty big machine. So today I have a couple things I need to do. I guess I could just wheel this over here. Show you guys. Let's see what's in frame. So I'll just do this. Hey Nick, thanks. Appreciate it. It's been a journey. It's been a super crazy journey. So you guys know that I use this I bought the Skyhook secondhand on like eBay. It was like, I don't know, maybe $1,000 and a couple $100 for shipping. But these things are like $2,500 or $3,000. And so this, man, you know, when you start doing these heavy parts, a good way to lift them is a challenge. Like it's a real challenge. You can get an engine hoist, but a lot of times the engine hoist won't go underneath a lot of these machines. Like, I don't know if you guys see, but Haas did that lowrider engine hoist, which is pretty slick. But this has just been a great. I mean, you see it. This is an inexpensive magnet. It says that it's got 300 kilograms, but I can tell you that I spent about $60 or $70 on this magnet, and it lifts these. These are small. These are actually small mold plates. I'll never do this again. I'll never make these mold plates from scratch again. I'll just buy pre-ground blanks. These were super cheap, and we had some projects that I was working on at the time, and so I thought I'd get a bunch of these, and lo and behold, it just ended up not being worth the time to size everything. But you guys can see that the fixture that I made recently is in the machine. The guys from M-Lock actually sent me this device. I'm going to show you guys this real quick. So this is my 5th axis vise that I've had for some time. And then this is the new M-Lock vise that those guys sent me to try out, play around with. And so I'm going to. This one doesn't have bolt holes in it. You actually have to use the mounting studs that go on the bottom. And this is a 52mm pattern. So you can use like the 5th axis setup or the Lang setup. I'm pretty sure it's all pretty much standard. The 52mm, there's a 52mm pattern and a 96mm pattern, but they're all pretty straightforward. And torn. I think I'm gonna pull this out of here. I'm gonna pull this out of here because I can cut this. I can either cut this on the Okuma or even on the 1100 if I need to. This is not critical at all. This is just a. This is that riser I was working on, and I was actually going to countersink all these holes and bevel this a little bit more for some more clearance. But those mold plates, I need to finish that last mold plate that was on the top right there. I need to get that finished, and so I plan on setting that up here, and I'll show you guys how I'm going to do that. If you guys have questions and you want to ask, or you want to just have a topic you want to talk about, I'm happy to share or chat or whatever. Just let me know in the comments. I'll do my best. Let's see what we got here. Someone says Sile X7 is it good? So Riker, just so you know, I have a business deal going with Sil, so I want you to understand that before I answer any of these questions. I've been getting a lot of questions about the X7, and I want you guys to know something. When you spend years making videos on YouTube, you build a relationship with the people that follow your channel. And I guess it's possible that if you're in a desperate situation that maybe a creator would betray his audience or just take a paycheck and just say something that's not true, but that's never been my MO. It just isn't. And so I'm super thankful that So Machine Tools stepped up to help support the educational videos that we're creating. But I want you guys to know that I'll do my very best to delineate between facts and opinions, right? And so this machine at the time of making this video is about $33,000 the way it sits. And that's with the tool setter, okay? There's only a couple of other options out there in that. Well, I shouldn't say there's only a couple of options, but there's some challenges here. A lot of guys want to go off and get, there's a couple of arguments here, and I'll share my opinion with you guys. You hear very often, go buy a used mini mill, go buy a used Fadal, go buy a used, I don't know, anything, VF2. And I can't disagree with that, but there are some things that I think are worth taking into consideration. There's no question that those machines that I just mentioned have a lot of rigidity, and they're like a little more industrial in nature. The issue is what happens if you injure one of those machines? And so that's where it kind of comes down to like your skill level. So before I get too long into my sidebar here, the short answer is I actually really like this machine, and I'm really impressed with it. It's more rigid than I expected it to be. It's much faster than it needs to be as far as like the rapids and stuff like that. There's the only downside I would say to this machine, this particular machine that's in the shop right here, is that it's a 3-phase machine. So if you want to run this out of your garage, you're going to need a phase converter. Now they do offer one that has, I want to say, a little bit slower rapids and a little bit less powerful spindle. That comes with I believe it's an LNC controller, and it will run on single phase. So take that for what it's worth. But all in all, I've been pretty impressed. The issue with a machine like this is I actually like the fact that Sal calls this a hobby machine. I think that's actually really cool. It doesn't feel like a hobby machine when I'm cutting on it. I respect it like it's a true vertical machining center. So for whatever that means to you guys, it's fast, it's pretty damn accurate, and I can't complain. You know, we in this shop here right now, I want to say it's around. I want to say it's about 90 something degrees in here. So I'm sweating like a I'm sweating like a fat boy. But anyways, uh, it's nice. It's nice to have. It's nice to have this epoxy granite casting. This machine is more accurate than I would have expected it to be, and I'll tell you, that's a big issue. Setting your expectations for any given machine. You hear so much like, man, I hate to say BS, but it's true. You hear these guys on the internet that like they make claims that like if you go back and you look through different companies' videos and different videos that have been on these different man, what am I doing today? Talking on YouTube is what I'm doing. If you go back and you look at a lot of the content that's been put out over time, what you'll see is that managing expectations is super duper critical. And somebody that I actually used to really respect a ton was kind of hard on me one day. They said, you wouldn't be happy with $1 million machine, they said to me. And I thought that was pretty unfair at the time. But I do think that there's a lot of guys out there that have extreme expectations when it comes to some of these machine tools. And that's a surefire way to be disappointed. I like this machine. I think it's a great value for the money. Its weakness is that it doesn't have a tremendous amount of documentation. And so if you're brand spanking new, how many amps on 3-phase? Scott, man, I wish, what's funny is we have an amp clamp over here. I should throw one on there. Yeah, so War Cover's talking about the War Cover's asking, is it War Cover? War Corer is talking about the Haas TM0, and it sure looks to me like Haas is taking a run more or less at Tormach would be my first guess. And you guys know that I've got a storied history with all these machines, man. I've just have had my fair share of, I don't know, shenanigans, I guess you'd call it. The thing with the TM0 is that by the time you actually fit that thing out with what would be like equivalent, it's pretty expensive. And so, like, just to give you an idea, I think that I looked it up the other day. It was like $28,900 for the machine with a tool changer. And then if you put like a probe on there, it's 55 or 60, maybe $6,200 now. It's gone up a little bit. You put high-speed machining on there, it's like $3,000. You bump that from a 6,000 to at least a 10,000 RPM spindle. In this day and age, if you're in your garage, you want a 10,000 RPM. I mean, I don't know why you wouldn't want at least 10,000 RPMs, unless you're exclusively milling steel with, let's just say, 3/8, I guess 1/4 inch or 3/8 diameter cutters. If you're going any smaller cutter than that ever, or you're doing aluminum, you want 10,000 RPMs. And so I've had a lot of questions about all these machines, the Okuma, the X7. I would buy a Haas again. I'm not like a Haas hater or anything like that. Like, I think I think Haas has done a great job of making things really easy to, they've cut the top off the learning curve. Like, their 5-axis stuff is like, with dynamic work offsets and tool center point control and your ability to single block through the control, the Okuma has been a monstrous learning experience, because a lot of these machines, like these bigger machines or Japanese machines, they're not like Haas is like a Ford F-150. You buy it and you get what you get, right? You can choose your options at checkout and then it arrives, but every control has the exact same workflow. Where if you go through like the Okuma control, there's like window after window after window of like check boxes, and check this bit for this and that bit for this. And it's like, the thing that kind of blew me away is that two people could buy the exact same machine from, let's just say one guy buys it from Hartwig back in the Midwest, and then one guy buys it from Gossiger out here on the West Coast. Even though it's the same machine from Japan, it won't operate nearly the same. Like, just running a tool change, like an M6 T whatever, or a T1 M6, however you want to do it. This machine, from what I understand, can actually have an issue where if you try to call the spindle number that's already in the spindle, it'll like alarm out. And in some cases, I guess if there's like a pot adjoining the spindle for whatever reason, let's just say you pre-staged a tool and you tried to call that, it would alarm out. So Gossiger wrote their own macro, which is G116. And so I'm gonna nerd out a little bit here for you guys, but if you're used to running machines and you know a little bit of G code, then you know things like G43, G54, obviously your work offsets, tool length offsets. It's very different. There's some cool things that Okuma does that I really like. Your tool length offset, it's actually a G56. So what everybody else might use for work offset, they use for a tool length offset. So they don't run G43. But check this out. You can have 3 different lengths for the same tool and 3 different diameters for the same tool. And when you call G56 for your tool length, and you instead of choosing H, let's just say the tool number, let's just say 10, you can just choose H, the letter A, and it will use the height offset from the A, value box inside the tool table or whatever. So you don't ever have to worry about your tool number and your G56 not matching, like your tool number and your length offset number not matching, because if you just use HA and you make it a habit to always fill that out in the tool table, it'll always be right. Where, as an example, this machine has an umbrella tool changer, and my Super Mini Mill had a tool change umbrella in it, and it only had 20 tools. But in Fusion 360 and in HSM Works, we had a tool library. We have 83 Cat 40 tool holders. So now what? In a Haas machine, you can't call an M6, a T27 M6 in a Super Mini Mill. So what you would do is you'd call M6 tool number, whatever, let's just say 15, and then you'd go G53 H26. And so it's kind of sketchy, right? You actually have to turn setting 15 off on a Haas machine in order to do that. But if you want to keep your tool library nice and clean, that's the way to do it. So let's see here. Yeah, so anyways, the TM0 I think is pretty slick. It's clearly aimed at the entry level market, the hobby market, things like that. And there's no question that there seems to be like this. When people are asking me about buying machines, the last thing I want to do is give you guys bad advice. This is something that you got to decide for yourself. But I think if you have something like this, as long as you're prepared to work on it yourself if you have to. You don't want to. You bought it. You want it to be perfect. God knows. But stuff happens. It's the way life is. And so if you're willing to take on the responsibility of being able to spin wrenches on your machine, these things are not rocket science. I promise you that they're not. I know it's a little intimidating when you bought something brand new and nobody wants to spin wrenches on a new machine. But as soon as the warranty is up on any of these machines, you're gonna be responsible for that machine one way or the other. And so I see all these guys that say, "Hey, don't spend 30 grand on something like this or on a Tormach. Go out and buy yourself a Haas mini mill or a used Fadal." But okay, well, what if you stuff the spindle into the table or into the work on one of those machines? I want to say the spindle cartridge for a mini mill is right around $5 grand, and you got to give them your core. But like on my mini mill, I couldn't actually even change the spindle cartridge myself if I wanted, because on all the next generation control machines, you got to have a service key to reset the spindle orientation. So literally every single setting in here, in the parameter, everything is here. Like every single thing you can change here's the rapids. The rapids are down here, like 30,000 millimeters a minute or whatever. You could turn them down. So this has knobs, 0, 25, 50, and 100. But if you wanted to turn it down to 10,000 so it's nice and slow, you could. This machine has a pretty cool function right here. It's called MPG Sim, and you press this button, and then when you crank the wheel, you can see it's obviously still in MPG mode. But when you put this MPG and you're running your program, you can single block through your program one click at a time, which is pretty slick. So turn that back off. Terrence, yeah, I'm terrible man. We have a bunch of stuff around here. This has just been the most hectic. This has been. I try not to drag you guys down with the the ups and the downs, but this has been one of the roughest. I'd say the last 6 months have been super rough for me personally. So this is my AccuBlast that I got from Peter, and it's awesome. And I'd like to get it on here one of these days. In fact, one of the guys was here. I mean, it holds on pretty decent. But yeah, I still have it, and I still love it. I'm seriously thinking about putting this thing on the Okuma. We also have a fog buster setup for this that we installed with the original magnet, and then I disassembled it. And I put it in some lock line. I printed out this housing for it. I just designed this a couple of years ago, but I put it in this housing. And so this is going to go up here somewhere. So this is nice and clean just for filming. I took the manifold off there because we had better reach for filming. And this is going to go like this. And then we'll be able to aim this at the tool, and we won't have coolant splashing everywhere. Scott says he was spinning wrenches on day one to get a machine through the door. I hear you. I honestly believe in my heart that if you set the right expectation on day one, you'll be happy with. You can be happy with any machine you buy. It's setting the right expectation, understanding the machine's real value, or not real value, but real capability. And so, like all these guys that hate on, let's say guys that hate on Tormachs. You see a lot of like the hardcore machinist community. They don't like Tormachs for whatever reason. But what if you want a machine in your basement, man? Like, what if you live in the Midwest, you don't have a garage, and you want a machine in your basement? This isn't going in your basement. That sure the hell isn't going in your basement. You could disassemble a Tormach, whether you bought one new or used, and you could get it into your basement, one piece at a time. I mean, what's that worth? You know? I mean, I don't know. I just know that it's a decision that if we're going to spend the money, we got to live with it. I'm struggling here today, fellas. I have no idea where. I have no idea where the. I kind of got out of here with the quickness this week, and now I can't find any of the tools to get this stuff out of the machine. Oh, there we go. Oh, that wasn't that pretty loose, actually. I bought this Tagara Vise. I'm actually a big fan of this thing. So you guys know that we have the Kurt DX6. Do any of you guys, man, I didn't realize this, but I've noticed the other day I was searching for vices online, just kind of looking around. I always kind of wanted an orange vice, but every time I've like messaged those guys or emailed or whatever, I've never heard back. Actually, I didn't strike that. I don't know if I emailed them. I might have just messaged them on Facebook or something. But I'm a big fan of this Tagara Vise, and this one, I bought this one specifically for this machine. This is the 660U. You can see it's machined on the edges, but the important issue is that it's the right length. This machine, when you close the door, this machine can go to all the full travels, and it's lined up nicely. Where with the DX6 or the Tagara 690, I wasn't able to do that. Right now, what I'm doing is I'm going to pull this vise out of here, and I'm going to throw the magnetic chuck up here. I was really kind of skeptical on whether or not I was going to be able to get away with using a magnetic chuck. Like, I was like, man, how much tool pressure are we really creating here? And so I put it on the table and gave her a go, and lo and behold, it worked out well. So it's kind of a mess. I normally just spray the table down with WD-40. I stone it, little WD-40 before I throw the vise on. I don't usually put like LPS3 or anything down unless like it's going to be there for a really long time. My setups just don't tend to last that long. Wish there was a mag chuck that worked on aluminum. Yeah, I hear that. I know that feeling well. Gotta put my safety glasses back on. I had to cut these T-nuts down this machine. So I'll show you guys something cool that I bought. Sadly, it doesn't fit on the X7. I'm a little bit bummed about it. Here, I bought some of this. It's from Octane Work Holding. It's rubber strip that goes in the T-slots. I had planned on putting it in the X7, but this thing has this weird, it's just a weird size. It just doesn't fit real well. I tried it in the 1100 and it actually fits pretty good. But this thing, it just won't get down. It just doesn't want to get down in there appropriately. So I bought it. I'll just use it when I get some time. But I really like the idea. I just saw a guy the other day in the Saw user group that had some of the stuff, but I think it's metal. I hope this is too loud for you guys. I'll check the comments in just 1 second. My tool setter's acting up. Not sure what's going on. I tried to probe in some tools yesterday, touch out some tools, and it kept staying down. So I gotta see if it's got some coolant or chips or something in it. Yeah, that blue rubber stuff is actually T-slot covers. Yeah, it's pretty awesome. So let's see here. I'm just wiping this down. Just clean it off. Doesn't have to be flawless, but I'll show you guys what we're putting on here. I would have never guessed. So this is it. This is a magnetic chuck that I got from Tool Lots. It's not an electromagnetic chuck. It's just a magnetic chuck. And yeah, it works pretty good, actually. I'm going to spray a little WD-40 down there before I put it on there. But yeah, that thing works really good, actually. Surprising. I'm actually using the Dijet. Where the hell was all the WD-40 at? Yeah, so we put that thing down. And it holds onto those big steel. Holds onto those big steel plates. Great. In fact, I put a 246 block down and I was pounding on it with a dead blow hammer. I mean, you can't get it to move. There's no question. But still, it takes some ugga-duggas. Yeah, so that's it. I don't line it up or anything. I just slap it on there just like that and put the clamps in and game on. It's ready to go. So yeah, I'm pretty pumped. It comes with a ridiculously. Here's what you turn it on with. It's pretty ridiculous. I think I don't know why, but I thought I had some spacers underneath this thing. Definitely seems like the guys that are like wizards do it with setup, do it with fixturing. It's like kind of like it's like a true art. You see these guys do some pretty awesome stuff. I'm gonna have to move this tool setter or this 5X vice stop. Actually, I'm gonna have to move the tool setter and the vice stop. I'm gonna have to move the tool setter because we have way too much travel. We actually have to get these parts are 14.4 inches in the X, and this machine I think has about 15 and a half, and we're using a 1/2 inch cutter. So like it's got to be pretty. I actually have to get everything on here, set everything up, and then kind of like actually tap the part around with the magnetism off, get it like where I want it to be, so that I have all like full cut, and then lock it down. It's pretty crazy actually. I've been thinking about using the Pearson pallet system a little bit more for some of this stuff. I guess Jay's moving again. All right. It's not the prettiest thing in the world, but it'll hold, and we can get past the edge. I believe we have to be able to get past the that edge. Yep, that's perfect. Because we're actually going to cut out. We're going to cut around here, and we're going to cut all the way past the bottom of the part. I'm going to slot on the far right hand side so we can break the chunk off. And then we're going to slot all that down and leave like maybe 10 or 15 thousandths. Then we're going to go all the way around. And right when we get to about, maybe having 20 thousandths left, I'm going to pause the machine. I'm going to tap the edges down so that it kind of folds down. And then I'm going to run that, run the feed mill around it over and over, the die jet around it over and over until that stuff falls off. It's been working pretty good lately. So I did that the other day with a rag that had chips on it. Tore me up. All right. It's kind of a bummer that I have to move the tool setter and everything. You guys working on anything fun or what? I can't remember how I did this. This just has two 3mm set screws that you back them out, and then you can lift this thing. I know you guys can't really see. There's not a lot of room in here. It just moves. You just move it right out of the way, and then you just get down in there with a wrench. Just put that over there for now. Just get it out of the way. Come on, a little bit. Do you prefer magnetic chucks with pull blocks or low-profile vice clamps for steel? So I bought these. Bought these right here. These are little toe clamps basically that you can get from Mighty Bite. They have a flat side, so they're non-marring, and they have a serrated side, and they work really good. They just go in the slot or whatever. But obviously with this you can't go past the bottom of the work. And so the one nice thing about the magnetic chuck, if it will work for the application you're using it for, or even, I guess even if you have to dial your speeds back a little bit, the one really nice thing is that you can get past the bottom of the part, depending on, where the chuck is at, or depending on your part, I guess. I make airplane kit parts, RC jet engine. That's awesome, dude. I make airplane kit parts and paintball guns in my shop. Currently doing a random job for some side money. I want to strangle their CAD guy for making me do tiny pockets, 1/2 inch deep with their 1/8 inch end mill. Yeah, or 600 thousandths deep. It looks like. Yeah, it happens, man. I had a guy in my industry, super smart guy, super capable, has a very successful company, and he wanted me to do some prototyping for him. And we had a little. There was a pocket that had a half a millimeter radius, so 1 millimeter tool, and it was like 13 millimeters deep. And I just told them, I'm like, man, this is like super unpractical. Like, we could have drilled it with like, I don't know, maybe like a 60 thousandths drill or whatever, and went in there, but just getting down there to clean that up is just super impractical. In fact, it's not uncommon for me to have guys, um, I guess you'd call them the inventors, that they'll come in with like a drawing. Sometimes they even have like their own Fusion file or a SolidWorks file or whatever, and they'll have something that literally has a square corner. Like it's square. It's like a square internal corner, a square on the bottom to the corner. Like literally, I guess we could manufacture with the EDM machine, but you never would. And more often than not, I would say that if I had to say that I failed, my biggest failures are my misinterpreting. Let me think about this for a minute. My biggest failures, I would say, I had people that I asked questions for, and they would answer me, and they were so out of their depth that I didn't know that they were out of their depth. As an example, I won't shame anybody, but we were in here the other day, a month or two ago, and a salesman came in, and the kid that works for me, he's just turned 21, and the salesman was trying to get us to buy one of this company's 5-axis machines, and he said, "Hey, this." I said, "Well, what's the tolerance? Like, what do you guarantee for positional accuracy, volumetric accuracy?" He's like, 2/10. I'm like, "You're telling me that the machine will hold 2/10 everywhere in a cut?" Absolutely. And I'm like, "Well, you don't want to be mean, but the guy's not intentionally lying to me. He just doesn't know any better. He doesn't understand how tall of an order that is. We're in a non-climate controlled facility. The Okuma that has 8 temperature sensors and linear scales on the X, Y, and Z is probably not going to hold 2/10 everywhere. It just isn't going to happen. I mean, I'm not. I'm making this too long-winded. My failure for sure was, number one, my expectations were incongruent with the machines I was dealing with. But how do you know? How else do you know? There's no one that teaches you that. There's no one that teaches you exactly which machine to buy, because when you go talk to the salesman, they all tell you that their machines are magic. So my expectations were pretty bad. The next thing was I continually worked really hard to make these machines fully automated. Like, I worked really hard. I planned. I learned to write these macros. I did all the stuff. And the truth is, this is just like this. I mean, yes, it does. When you put a tool setter and you put a probe in there, it can do work without you. But by and large, when you start, if you're going to make 10,000 of something, there's a very different mindset than if you're going to make 1 or 2. Very, very different. If you're going to make 1 or 2, you're going to most likely take a very slow, methodical, calculated approach. You're going to check, double check, and single block. You're going to cut, rough, you're going to pre-rough, rough, pre-finish, check, pre-finish again, check, and then you're going to finish. It's like, if you're really trying to hold something, creep up on something really accurately. I was going to do a video about this. Maybe one day I will, but since you guys are here late, and there's 51 of you, I'll tell you how I did this. A lot of times I set my Z at the bottom of the part. So let me grab this. Okay, this is a perfect example. Actually, so the magnetic chucks. Whatever. What the hell? We'll stick it down. All right. So let's just say that we've got our part. Actually, I'm gonna lay it the other way. You guys will get a kick out of this. Gotta go a little farther. Okay. So we'll just leave that. All right. So I put my Z at the bottom of the part, and I'll tell you why. Because when I look at my readout on my screen, I want to know where the machine thinks it's at. All right. So this is a little bit of a cheater move, I guess you'd say. But these are a Mitsui gauge block set. This is set number 516404-26. But just for an example, you can see that this gauge block has a hole in it. It's not a traditional rectangular gauge block, but let me just tell you what you can do. I had pretty good luck, and I ended up not needing to do this. When I made my next generation of tooling, this is a perfect example of where I over-engineered something. But what I did was I had a pallet and I was cutting my mold component, and I was worried about the expansion. A lot of times, these guys that are newer to machining, when they think of thermal expansion, they're thinking part, they're not thinking machine. The part is so small, it doesn't really suffer from very much thermal expansion. For the record, just so you guys know, it's like 6 millionths of an inch per degree Fahrenheit. So you can go do some math. That doesn't really apply here, but if you've got a machine that's 10 feet tall or 8 feet tall, it can make a big difference. If you start off in the morning at like 65 or 70 and it's 105 in the afternoon, that machine can grow substantially. And not only can the column grow, but as the spindle heats up, it pushes heat out into the head, and the y-axis will grow. We've actually experimented here in the shop running the spindles, letting heat build, and we actually go over to the EDM, which is very accurate, and we could see that we were cutting parts, and as the head would grow, the parts would grow by like, a thousandth at a time until everything fully stabilized. But here's the trick. If you put your z-axis at the bottom, down here, and you want to come to this, let's just say 2 inches. I'm gonna jog this over. So here's what you can do. I did it with a square gauge block because, well, I had them. You set your Z down here. Then you take, this is a 2-inch gauge block. I didn't have the 2 inch because it's tied up, but you just put a 2-inch gauge block right here. And now what you would do is you'd put a hole in the bottom of your fixturing. Now this is bolted down here permanently. Now you do all your cutting, you do all your checking, and before you go to take your final passes, let's just say that you want this to be at 2 inches flat. You might rough it to 2.010, so 2 inches and 10 thousandths, right? Now what you'll do is you'll take a 5 thousandths cut, a pre-finished cut. It's the exact same tool path as your finished cut, but it sits 5 thousandths up. This is really important because you want to keep the tool load identical. So you take a 5 thousandths cut, and if you trust the machine, you're good. You go in there and you measure, and if it reads 2.005, it doesn't touch anything. It just proceeds to the tool path and rock and roll. However, if it reads 2.006 because you're coming up a little bit short, or if it reads 2.004 because you've cut too deep, it'll correct the tool length offset for your next tool path, and then you're dead nuts on size. But I noticed that sometimes when I would start running parts in the morning, and I ran some in the morning and some in the afternoon, that I would get them to wander. Sometimes I could hold a couple of tenths. Like, it wasn't uncommon for me to hold 2 tenths, but there also were times it would be 6 or 7. And I finally decided that if your machine doesn't have linear scales and it's just using the encoder and the servo from the ball screw, it's only guessing where it's at. So what I did was I wrote a macro that would go over here and it would touch this, and it would reset the work offset exactly 2 inches from the top of my 2-inch gauge block. And so we had a perfectly accurate reference now. So now we basically went back and kind of recalibrated the machine during the cut, and now it would go back to cutting within a tenth or two. The other way to fix this is just don't cut stuff that far apart during the day. And so that's why when I made all my new fixtures and I didn't want to tie up the gauge block and stuff like that, and I didn't want it in there because it was collecting chips, and it was just making a mess. But there are ways to kind of, I guess, work around your challenges if you're willing to just put in a little bit of time. What about pallet jack to move the sill? Yeah, I move this with the pallet jack. Yeah, it does move the pallet jack. Yeah, I'm not sure what the specific. Hold on, I gotta wipe my brow off real quick. I've had a bunch of people ask me about the height of this thing, and to be completely honest, I'm not exactly sure. For the record, I'm probably 5'8" right now, so whatever that is, it's probably about. And it's at. Here, we'll put it at max Z. That's max Z right there, and so I don't know exactly how tall it is, but I doubt that's 8 feet. It's probably just short of 8 feet, 7.5 feet, something like that. I'd imagine that it's on the spec sheet. Yeah, we did get an Okuma 5th axis, yes. Does this machine have a chip evacuator? You know what? I didn't know that you actually can get one, but no, mine doesn't. This one just has a chip. This one just has like a chip tray that pulls out. It just you can slide the whole coolant tank forward. The machine rides on 3 feet, which I think is pretty cool. The chip tray slides out, but you can put a chip evacuator or a chip chute under this. There's no question that this thing, if you were making smaller parts, or I guess parts that are inside the work envelope, this thing's a little workhorse. I've been pretty impressed with it, to be honest with you. So, we'll see. We'll see how it holds up over time. You never know, right? But by and large, I've been pretty pumped. Let's see what we got here. Do you guys, can't believe there's so many of you guys hanging out. I'm surprised on a Saturday night. You guys, shame on you guys. You guys you're not supposed to be like me. You're supposed to get out there and have a life, just do something you enjoy. Don't live in the shop. My wife had to fly back to the Midwest because her grandmother had some issues. So I figured since she's not home, there's no point in sitting around watching TV all night. Keep your eyes peeled because in the next week or so, I'm going to drop the video talking all about work holding. We're going to talk all about some of the different options, why you would choose it, what the strengths and weaknesses are. We're going to cover all that stuff, and should be pretty awesome. Harindu Gamlath is saying, Jay, does the still come with a Siemens controller? Why didn't I go with the Siemens? Well, completely honest, to be 100% honest with you, let me just say this. I'm not unhappy at all with the Syntec. A couple of things. Let me just tell you what Syntec told me. So Syntec from here in California. They said that apparently Syntec is a pretty big company, like a very big company in Taiwan. And this is basically a Fanuc clone. That's what they told me. And while it's not very popular here in the United States of America, allegedly, according to them, it's like number 2 in Asia, behind Fanuc. And they OEM controls for people like Fadal and a variety of other companies. And this machine has a Syntec control, Syntec servos. I've tried to do some research, and I'm waiting to hear back. Here's my guess. I think that the Syntec control, like this actually has something called, if you guys get bored, go do a web search for Fanuc HPCC. It's Henry, Paul, Charlie, Charlie. It's a high precision contour control. It's a very expensive option from what I've been told. But from what I understand at the moment, this machine is actually a little bit more bang for the buck. It has a bigger screen, which I really like. And I believe it has a little bit more look ahead, a little bit more memory, a little bit more processing power, but it doesn't have that super robust back end support. And so I was talking to Aaron Powder. I don't talk to Aaron a ton, but I've always liked Aaron. He's always been a straight shooter. He's always been good to me. And he basically, after I had already made the deal or whatever for creating these videos and using this machine and stuff, he was like, Jason, you should have got a Siemens control. And I'm like, well, whatever. We got what we got. It works good. But that's why. If I had to do it over again, I don't know if I would switch or not. I really like this big screen. I can't say too much because there's some stuff in development, but there's some other stuff going on in here. When you go into this tool tab, like there's a probing functions. There's some stuff going on that's pretty awesome. All the tool setting stuff, center cutting. There's tool setting screens and stuff like that. I don't think you're going to see Siemens be so willing to develop new screens and functionality and stuff like that built right into the control. And so, yeah. Hope that answered my question. Who actually makes the Haas controls? Haas. I believe that's all custom. I've seen a lot of comments here in the last, I don't know, it's gotten worse than last year about the stuff homemade in China thing. I hope you guys understand that I don't know of a machine that's actually made fully in America that's like an industrial level machine. Like Haas told me when I was at the factory on my tour that most of their cast iron came from Asia. And I mean, I don't knock them for it. If you can't get it in America, you can't get it. I once watched a documentary that said that all the avionics and glass for the United States military's helicopters comes from Japan. Like, we don't make any of it here in America. And so, uh, yeah, I don't know. I know that the Haas. I was told that the Haas control is written on top of Linux, not Linux CNC, but Linux as an operating system. And all of those boards are highly proprietary. In fact, I'll tell you guys a funny story. So the guys from Syntec were in the shop, and this is where the USB key goes right here, if I can get it open. And one of the guys that works for me, was telling the Syntec guy, hey man, don't leave a USB in there, because if you break it off, this thing's probably pretty expensive. And the guy from Syntec's like, yeah, that's like probably a $30 board. Well, the one in the Okuma, if you break the USB off in the Okuma, they told me it's like an $8,000 board or something crazy. So, food for thought. Yeah, Joshua says it's cool that Grove has an assembly plant for their mills in Ohio. No, I mean, look, I'm happy that Haas does machines their castings and does their final assembly and stuff like that. But I mean, if you look at I guess the point I was just making is that you can't put American parts in a machine that don't exist. So if there's not a company here in America that's forging and grinding their own linear guides and their own, you know, high-end bearings, and if there's not a company here in America that will make that circuit board cost effectively, that runs, the screen or the boards that run behind the, in the control, just, it's never going to be made in America. That's just all there is to it. Harindu Gemlath says, honestly, I'm Asian and I've never heard of that controller until you got that mill. I'll look into that for a retrofit on my old Okuma lathe. Was considering the Siemens 808D. Yeah, I don't, just so you know, Harindu, I don't want you to feel like I'm trying to persuade you. I do think, I 100% think that the Siemens is the more like supported and robust option. But I think that this might have a little bit more bang for the buck. That's all I was saying. And yeah, look into it. You could, if you're here in, if you obviously you speak English, you're typing in English, you probably could call down to the Syntec and find out. Let's see here. I have a Herco and heard when they bought Miltronics, they just relayed their own face over their software. Yeah, I have no idea. That's the machine tool industry. So I don't know if I think I've talked about this already, but when I was going to buy that Matsura, and it's kind of messed up. Like, if you go to the car dealership, they would never try to sell you last year's car without telling you it's last year's car. It just wouldn't happen. And Haas has such a high volume of inventory that more often than not, when you buy one of their machines, I think you're going to get a machine that's probably brand new, like brand new, like within the month. But the guys over at Selway, they were going to sell me this Matsura that was a 2019 machine. I guess it was a 2019 machine that got delivered right in like the beginning, like the early months of 2020, before the pandemic kind of hit hard here in America. But what's interesting is they never even brought that up at all. Like, it was never even a consideration to tell me that it wasn't, like, I guess, a current model year machine. You think, hey, I'm shopping in the middle of 2021. You'd think that you're buying a 2021. Ryan says, I don't have to use G43, no H or D. Ryan, what are you talking about? On the Herco, it doesn't require any G43 call. In the code, it doesn't even require it. And are you talking about programming from Fusion, or are you talking about running from like a conversational? Hey, Nick. I haven't done one of these live videos in a long time. All right. Well, it's getting late. It's starting to slip a little bit over here. I'm gonna pull this out of here real quick. think I'll park this at the front. I'm not going to put the steel in here tonight because the table's in the way and all this portacle's in the way and all this stuff's in the way. This thing alarms when you hit the soft limits. Let's see here. Joshua's asking me if I have any experience with buying used machinery. Joshua, I do not. I can tell you that I would feel a lot differently about buying used machinery if I were buying it for specifically for a hobby. And that's something that I really struggle with. Like I totally let me just tell you about a conversation that I had recently with a guy. A guy called me. He had questions. He knew that, he knew basically that if we had the Haas machines and the Tormach machines and the Sill machines, and he just had some questions. And he has a Tormach 440 right now and wanted to get something bigger and badder. He's considering a mini mill, considering an X7. And so we got after this conversation, and I said, look, I don't want to be disrespectful, but have you ever crashed your machine? He's like, oh, yeah. And I said, well, let me, not to be like, I'm not trying to pry here, but when's the last time you crashed your machine? And he's like, 3 days ago. And I'm like, that's a perfect example. This guy has some skills. He understands the fundamentals of machining, like set and work offsets and programming and chip load and all this kind of stuff. But he's still making mistakes 3 days ago. And so can you honestly tell me that guy should go buy a used VF2? Because if he stuffs the spindle, it's like $7,000. So even if you go buy a cheap VF2 for 25 grand or 30 grand, you have this beautiful machine. It's heavy, it's rigid, at least compared to all these. It's heavy, it's rigid, it's, it can be made to be accurate through either, mechanical correction or software correction. But if you crash it, the cost is substantial. If you end up having to move out of your home, something like the 1100. I know when we took my little X5 home, we just took it in a Penske truck with a lift gate. We just grabbed it with a pallet jack, wheeled it up onto the lift gate, pulled it up in the truck, and off we went. And so there's benefits to having machines that are lighter. Boone just finished his last part. Boone, you're grinding, dude. I'm impressed. I like it. Boone Freeman's out here making parts in his garage. Boone, what do you run? You have a VF2, don't you? Don't you have a VF2 with a rotary? Terrence Ganley says, just for everyone to read, you can fit a Centroid Oak controller on the X7. Yeah. I'm fighting with Fusion's adaptive tonight. Keeps adding phantom cuts on vertical faces I already cut. I'm about to give up and pocket this bastard. Yeah, I'll tell you, Scott, I really like Fusion, and I'm going to talk all about this. The Okuma's almost done. It's almost like ready to rock and roll. In fact, I'll tell you what. We'll just stay here. I struggled greatly when I had the VF2 with the rotary. That stuff treated me well, just for the record. There's some things I didn't like. I don't like the fact that Haas is kind of like protects you from yourself. If you don't have access to any of the parameters. I don't like that. But the machine itself worked pretty damn good. It was brutally easy to use. It was brutally easy to set up. Even when I was learning just the bare basics for 5-axis and 5-axis, not only 3+2, but also for simultaneous work, it was good. It was good. It was easy to learn. It was a great tool to learn, and it had some capability. There's no doubt about it. But at the end of the day, we had a new kind of like workflow that I was working on, and so we really wanted to move to a full 5-axis machine. But when we went to the 5-axis machine, the game changes, right? When you have a machine that's, let's just say 300 grand, we'll just use that as a nice round number. When you have a machine that you spend 300 grand on, or 200 grand, or 250, or whatever you spend, right? You can buy cheaper machines. You can go buy, 500 for 150 grand. But if you buy an expensive machine, you don't want to crash it. I mean, shit happens. I guess I shouldn't swear because we're on YouTube, but stuff happens. It's going to happen. That's just all there's. There's going to be bumps and bruises, and that's the way it is. But if you're cautious and if you follow a very disciplined protocol, you can reduce this stuff. Like, I decided that I was happy with the tool paths that Fusion creates for me. I don't I don't need more than that software does for me right now. All of the things that I want to do, all the things that I have planned to do in the future, I've already kind of done it in Fusion, and it's capable. It's capable enough. And when it won't do something that I want, like you're having problems with these phantom passes, I just draw in my own sketch geometry to drive the tool path. So I'll drive a new bound, I'll create a new boundary, or I'll create a new sketch, or a new surface, whatever I need to kind of get the software to do what I want. I know that that's not as pretty and it's not as user friendly as something like one of the high end versions of Mastercam or something like Esprit, but it gets the job done. And more importantly, I'm not tied to it forever. If I want to dump my cam software next year, I'll just dump it and move on to something else. If you spend $25,000 or $30,000, that's what Mastercam costs for like the full 5-axis package, 25 grand. You're kind of in that system for a long time. It takes a long time to make it worth it. We looked into Hypermill, but that was even more. That was like almost twice that. I think it was like 44,000 or 45,000. So I struggled. I struggled with this because I wanted to make the right decision. And so let me tell you where I ended up before I babble on any further. We ended up with Fusion 360 for our software. We also have SolidWorks with HSMWorks that's live and active and up to date, but we primarily use Fusion 360. I hired a company to make me a post processor. They did 4 different revisions, and I think this 4th one is finally working. And then I invested in a company called NC Simul. Now, if you've heard of like Vericut or Camplete or any of these kind of companies, that's what NC Simul is. It's a simulation and verification software. And so 90% of the time, I will not use NC Simul. It's only there so that when that machine starts bobbing and weaving, we can check all the boxes and make sure that we have clearance when we absolutely need it. And it was cheaper than investing in the CAM software. And the nice thing about NC Simul is that if I make a hand edit and I save that program, I can rerun that hand edited program. Let's just say I change my feeds and speeds on a couple of passes or a couple of spots in a long program. I can rerun that through NC Simul to check to make sure that I didn't miss a decimal or miss a, accidentally delete a line of code that's going to make the machine crash. And not all verification softwares allow that. A lot of these verification softwares, like as an example, I shouldn't say a lot, but Camplete as an example, reads, you have to use their post and it reads from the software. It does not read handwritten code. Vericut does read handwritten code. I'm pretty sure Inventor HSM is just the same. It's the same engine basically as Fusion. Yeah, I do have. Yeah, Harindu is bringing up a good point. Fusion does have that. Just so you know, I rebought that extension at $1,100, $1,120, and the $400 a year, whatever Fusion is, I think I get it for like $350 a year whenever it goes on sale. The $350 a year is a smoking deal. It's beyond contest. All the capability, the CAD, CAM, 3D printing, point cloud reading, all the stuff that the simulation stuff that it can do, it is beyond a deal. When you start getting into like the $2,000 a year range, this is where I kind of griped about it to the guys at Autodesk. I'm like, look, man, at $2,000 a year, after 10 years, you spent 20,000, you have nothing. You have no equity. So why don't I just bite the bullet and buy Mastercam for 10 grand today? And then for the exact same yearly payment, I get that thing up to date. So you do have to bite the bullet. But if you ever stop paying, you still have software that works. That's my biggest issue. I know that CAM software is going to get better. I don't doubt it for a minute. Collision detection is going to get better. Simulation is going to get better. Editing, modifying, 5-axis, whatever. Wouldn't surprise me someday if we saw like a multi-axis flow or a multi-surface flow on inside Fusion 360. It's not there yet. But it is an issue. So yeah, I know. So Alexander Bergeron, hope I'm not butchering this, buddy. Alexander Bergeron just said that Autodesk bought Camplete, and that is 100% true. Check this out. So I looked into Camplete. So just so you guys know, most of this verification software is very expensive. I called Vericut for one license on one machine. It was like $21,000 or $22,000 for the verification software. Camplete, I want to say was about $19,000, $20,000 in its day. Now you can go and sign up for a prescription, dude. I've got to be like, you think I've been drinking or something. You can sign up for a subscription of Camplete at Autodesk today, and it's $3,800 a year. That's like a smoking deal. So if you just want to try something out, or you're just trying to flesh something out, that's a really manageable cost. the downside is that after that $4,000 investment, you own nothing at the end of the year. So that's why I chose to invest in NC Simul, because you get the verification and you still own it when you're done paying for it. Yeah, Scott, I'm not real sure about the Inventor stuff. I haven't looked into it. I'm pretty pumped with Fusion. I run it on a MacBook, so I have a gaming laptop right here that I work from, but I also have a little MacBook Pro that I drag around with me everywhere because it's super lightweight. And like if I'm traveling, I can just pop Fusion open and update to the tool library or whatever. And so I really like the fact that it runs on both platforms. Yeah, oh yeah. So Alexander, I don't know why you redacted that, Alexander. That's okay. If you're welcome to say that. If you're saying Complete does optimization and stuff like that, yeah, I don't know if, to be completely honest with you, we've already got started our license with NC Simul, but I'm still waiting. According to Gossiger, we just got the through spindle coolant pump. You can see this gigantic thing here is a through spindle coolant pump. I would have never guessed, but we just got that, and we are waiting for our laser tool setter. I ordered a Renishaw NC4 laser tool setter for the Okuma, and I guess there was like some mishap, like a fork truck ran it over or something. I don't know, and so they had to like ship one in from Japan. So it's supposed to be here this coming week. So the machine's like it's itching. I put coolant in it, and now the coolant pump won't run. So like I don't know. I'll figure it out. I told you, manage your expectations. That's critical. I'm actually we're getting more people on this feed than I'm just stunned that on a Saturday night we have 72 of you guys hanging out. It just makes me laugh. All right, so any other topics you guys want to talk about? I mean, we pulled the Vise out of here. We put the magnetic chuck in here. We've talked about buying machines, the control that's on this machine. Yeah, Joshua, I didn't know either until I went to look at the Matsura. The Matsura had a Renishaw laser on it. That's how I found out about it. And then there's a guy on YouTube. It's called Kruger, CRU. I think it now maybe. I don't want to butcher this. It's called Kruger Machining. Could be a K, could be a C. I can't remember. But I talked to the gentleman. His name's Craig. Super nice guy. But it's called Kruger Machining. And I saw on his M465 axis he had a laser tool setter, and so I knew it could be done. And so that's how that kind of all worked out. Yeah. Oh, I can't even see the thumbs up. Let me see here. If you guys are enjoying this video, do me a quick favor, pound the thumbs up. It'll, I don't know, it really doesn't do anything, but I appreciate it if you do it. We're such a like a niche community that I just don't see like the pure machining. I mean, if you're making all kinds of tons of content and you're like doing like these like super like, I don't want to say clickbaity, but like really focused thumbnails of like we're cutting 500 inches a minute or ripping through a shredding aluminum, then maybe you'll get a ton of views. But I just don't see us ever getting millions of views. So I make these videos so I enjoy the live ones specifically. I make them because I enjoy having this two-way dialogue. And then when we get done with this video, I turn it off here, I make it private, and I put it up in the Patreon area for my patrons. I appreciate those guys supporting me. So everybody wins. You guys get to hang out with me. I get to make some content, and my patrons get something that's available to them, in the future. Check out the orange Delta 4 Vices for the Okuma. Yeah, I will. I will check out the orange stuff. Yeah, I definitely like it. Jay, why did I consider the laser over the other? Does it really make a difference? I'll show you why. I'll show you why I chose the laser. That's a fantastic question, by the way. That is a fantastic question. Oh, if I could only find. I'm coming, I promise. I've got all these tools. I guess I broke all these tools down, but just for the record, you guys can't see this, but this was a 10,000. It's broke off, but this was a 10,000th end mill, so like 3 or 4 sheets of paper thick, and so it would touch off on the traditional mechanical tool setter or optical tool setter. believe it or not, that machine actually uses a radio tool setter. It uses a radio signal. But I chose the laser because we do run a lot of very small tools. It's not uncommon for us to run a 20 or 30 thousandths tool a lot, and so that's why I chose it. Let's hear the Okuma machines look like good workhorses. The company I'm working at bought a bunch of horizontals and verticals that should keep up with demand. Any thoughts on the new Haas Vises? I'm pretty sure that those are just private labeled Kurt Vises, are they not? I could have swore it said like Haas DX6. I thought that's what it said. Yeah. So someone's asking me, did I look at different controls when I looked at the Okuma? Here, I'm going to unplug my phone and we'll just head over there. So this is the Okuma here. And I did look at some. So here's the thing. This machine is basically an Okuma MU400, number 2, or the version 2. So there's an MU4000, which has a B axis. So it tips this way, not this way. And then there's the 400. So this is basically an MU400 that is spec'd out basically it's like a spec machine. You can get a couple of options, but like you're not changing the spindle on this machine. This comes with a 15K spindle. That's just the way it is. If you buy the MU version, then you can get a 30,000 or 20,000 or 10,000 or whatever you want. I know that Okuma does offer a variety of different controls, or they used to, but this was not an option. This is the only control that was available to me. And this is the OSP 300 MA-H, and that's all that was available to me. If I could, a couple of things. I wish I could have had a little bit smaller platter. Like one of the challenges is that when you tip this thing up, you have to reach down as far as your part is. So whatever that works out to, right? So obviously it's going to come from this direction, but people don't realize that when this thing is tipped up, you have to reach down far. And if this thing starts to go even farther, then you've got to go down even further. So reach becomes a real issue. And so this machine only allows for a 9.45 inch long tool, which would work out to something about like that. So you could have some reach issues. What I basically did is I simulated all the parts that I wanted to make before we bought the machine. And the first time I tried to simulate it, it looked like I wasn't going to be able to reach the parts. And then I kind of took my time. I kind of redesigned some of the fixturing, and this will allow us to make some of the small parts that are the size, basically of a softball, bowling ball. And it will let us make some of the bigger parts too. So this thing has 31 inches of travel on the X, 18 on the Y, and it rotates. This table rotates on an axis that's about 70 millimeters above the table. And this machine is 69.86 millimeters above the table. So when this table comes up and it slides all the way back, you have about 11.5 inches from the spindle center line to your max reach. So. All right, let's see what we got here. What are my plans for 5th axis? I'm not 100% sure. I've got this. Hold on, I'll show you guys. So I've got this. This is my my little 5th axis vise. It's been good to me. See, I got the jaws on backwards. And then the guys over at M-Lock mailed me this to try out. It's the M-Lock. I believe it's I don't remember the name of it. I believe they call it like a 100 Slim or 120 Slim or something like that. But it's got the 4 bolt pattern. And this is for Rock Lock or the Lang 52 millimeter setup. And so probably we'll run this for now. And you see it's got these dovetail jaws and stuff on there. So more than likely we'll do this. We'll do this, or we'll do the setup I already made. And I'm going to build some custom fixturing for sure. Yeah. So like this is the riser that I made. This is just a little riser that I made for the 5th axis vise. And I made this on the X7. I don't know if I'm going to buy. I haven't decided if I'm going to buy any of the 5th axis stuff just yet, or the Lang stuff. There's no question that I'm going to have to invest in some work holding. I know that, but I know that so many of these lessons so many of these lessons, they really can't be taught. They can be learned over time. And so the last thing I want to do is go out there and spend a couple $1,000. Every dollar is precious, So I don't want to go spend a bunch of money on a bunch of fixturing and tooling only to find out that I'm going to use it once every 6 months or not at all or don't need it. And so I have a lot of fixturing here, a lot of aluminum here, a lot of scrap steel here that I can make a lot of the stuff that I need. So I'd rather just make it. If I can make it, I'd rather just make it because I can design it the way I want it. I don't just have to take what they give me. Like as an example, that thing, I like the idea of having this machine because it has a very kind of limited Y travel. You need to be really careful with your fixturing. You don't want all of your parts sitting way up off the table. When you tip that thing over, you won't be able to reach it. If you've got something like this and you tip it over, you can't reach it out here. You know what I mean? So it's tricky. I don't know if I'll make a 0 point or not, but we'll just see what happens. I probably won't make the 0 point. Like I might make something that like holds an adapter plate and then something like that. Yeah, those are cheap. Just all the red is curved Vise. All right. Yeah. So, man, it's crazy. So there's so much work. Our work's been backing up now for literally months. Like I'd say like 10 mold cavities that need to get machined. I have a lot of work to do. So I really hope we can get the Okuma up and running this week. It's been a long time since we've had. When I let the VF2 slip out the door, I didn't realize how long the wait was going to be for a new machine. Someone's asking me where to buy raw material. We just buy it from a local metal store here in town. It's called B&B Specialty Metals. They sell steel, aluminum, whatever you need. I know that you can get stuff from like All Row or Online Metals, just depending on what you need to do. What's nice here is that there's a scrap yard, so you can just go out there and walk the scrap yard, like remnant scrap, whatever. But like it's like cutoffs, and so you can just grab all kinds of stuff that's already pre-cut. Ooh, Harindu's on his game today. He just asked about our compressor. So you guys know that we've been using the Eastwood compressor until today. But the Okuma absolutely murders the compressor. The minute you turn this thing on, it starts bleeding air. I mean, it's brutal. And if you want to run something like that with air blast, it isn't going to cut it. And so luckily this building has 480 volts, 483 phase. So we just ordered a compressor. I agonized over this, and I know I'm going to catch some hell, but I'll tell you guys anyways. I agonized over this. One of my buddies has a Gardner Denver. Here in town, you can buy Atlas Copco. They have O's in here in town. And so I really struggled to choose a compressor. I really like the idea of having something that has a lot more CFM, but we bought something that has like 40 CFM, 40 or 42, I think it is. I would have liked to have something that's like closer to 75, but 12 has got us to where we're at on that little buzzard compressor, so I can't complain. But we have one coming that's 40, and I got the compressor, and I got an air dryer, and I bought it from Tool Lots, believe it or not. So it's actually built in Taiwan. And so I don't know if you guys have ever been overseas. I've actually had the pleasure of going to both Taiwan and China, and I can tell you that generally both countries can make perfectly capable, good, high quality equipment. But I really struggled because the difference was substantial. For an Ozin that had a tank, basically it was a screw compressor, tank, built-in air dryer. It was $10,000 for that compressor. Or I could buy a screw compressor with a dryer for like $4,500, $4,800. It was half the money. And so I guess if I have problems with it, then shame on me for going the cheap route. And if it works great, well, then it's a win. $5,000 is $5,000. So Someone's saying, why keep the cylinder with a VF2? It really wasn't that simple. The Haas machine, it was time for the Haas machines to go. That's all there's to it. The machines were capable, but they really weren't. I don't know how to say this. They just weren't the right tool for the job. Is probably the best way of putting it. They just weren't the right tool for the job. They were capable. They were easy to use. They were as accurate as most people would ever need. Probably 99% of the world doesn't need anything more accurate than that. And a lot of those machines, I just had a pretty interesting discussion with a machinist here the other day that used to run all DMG Moris. And we both pretty much agreed that more often than not, like 99 times out of 100, you can actually accomplish what you need with the Haas machine. But there are some instances where, like, if you're surfacing or something like that, it's just not, it might not be your first try, right? Is the machine going to make the part accurately on the first try? And if you're only making one, if you've got like one piece of mold steel, let's just say you got a $1,500 piece of mold steel in your machine, and you only get one try, what happens when you blow it? Then you blew 40 or 50 or 60 hours of machine time and the material cost. I mean, it's like, that's not ideal. And that's really where I think you see the jump from machines like the Haas to Mazaks and Okumas and, machines that are just a little bit more robust, to simply put. Pre-tensioning the ball screws makes a difference. Having roller linear guides as opposed to ball bearing linear guides, it makes a difference, No, I did not. Are you kidding me? John Saunders bought an Okuma? Good for him. Good for that guy. That's awesome. I love that, dude. I've said it for years. I've told people for years, like, the M560 cannot be beat for value. Like, the same way that I feel about like Prusa printers and stuff like that. Like, the M560 isn't the cheapest machine, but 40 inches on the X, like 22 inches on the Y or something like that, and they blow them out at the end of the year for 99,000 bucks. That's a smoking deal. And Akuma's high cut is probably as good or very close to Haas's high speed machining. Hell, it could be better. These machines have super NURBS, or now they call it hyper NURBS or something like that, I think. Scintillating one is asking me about a welder. I'm not sure. Well, I guess I got this mostly set up. I don't have any tools in here because the tool setter went down. It's getting stuck on. Not sure why. I got to take that thing apart or mail it back maybe. But this thing is set up. If you guys don't have any more questions, I'm probably going to wrap up for the evening. I was thinking about making some cuts, but I don't feel like dragging that stuff around and setting it all up tonight. Actually, you know what? I'm going to jog this head down a little bit before I do this. If you guys have any more questions, ask them now, and I'll do my best to answer. Super hot. I think DMG Moris are great machines. We looked at one, we looked at a DMG Mori over here for a 5-axis machine, but they told me I think these guys. I think that they literally think that everybody's a tire kicker, and I don't think that they're willing to. I don't think they're in reality sometimes, and so I tried to tell these guys, like, man, I'm dead serious. I'm buying a 5-axis machine, but they basically told me it was 400 grand to start for a DMU 50, third generation, because that's the machine we were looking at, was a DMU 50. So I don't really know. What would you pay for this machine? Just depends on how you get it outfitted. Someone said, how have I found the cell lack of support? I haven't, there's no question that SIL doesn't have a huge support network. They're fully aware of this. I haven't found it to be a problem because I'm pretty experienced. If someone was brand new though, I could see how it would be a challenge for sure, 100% for sure. How do we hold molds? It just depends. Some of the cavities that we have, we put holes in the bottom and we hold them from the bottom with bolts in fixturings. Um, Sometimes we just toe clamp them with those clamps that you saw over there. It just depends. It just depends on what we're doing. I've been looking at one of those electromagnetic chucks for this thing, but I'm just not sure if I like the idea of, I don't know, it just kind of freaks me out a little bit to be running a separate electrically powered device inside the machine. Just the machine's so expensive. If I were to like short something out or something went wrong, I would never forgive myself. More like BMW style. What's my favorite material to cut? I don't really care. Just whatever. I mean, I think that aluminum's the fun one, right? It's the fun one. It's the easy one. That you can miss the feeds and speeds by a mile, and the machine will just plow right through it most of the time. But when you start cutting stuff that's a little bit harder, you got to be a little bit more careful. I remember the first time I tried going like balls to the wall in tool steel, and it work hardened on me. That was a scary moment. Start screaming. Have I ever messed with? Do you have to hire a rigger to unload the sill? No, you do not have to. And I did not. I rented a fork truck and had one of my buddies come over here, and we just grabbed it, uncrated it, lifted it up, set it down. We grabbed it with the pallet jack and put it in place. Simple as that. So pretty straightforward. But you will need something to get it off a truck if you buy one. Have I ever messed? I have not done any machining cast parts. No, but you know what, Scott? There's a really good video that Peter Stanton has where he built some pretty badass fixturing for holding castings, and then basically he uses a pretty sophisticated probing macro to kind of pick up the casting and set new date, skim it, set new datums, and work from there. Someone asked where my old 6040 is. It's right down there. We ran it the other day. We actually use the 6040 a lot. I shouldn't say a lot, but we use it to make all the baseboards for all of our vacuum forming molds. So anytime we're building a tool for vacuum forming a product, we build a baseboard for it using the 6040. So it still gets used to this very day. Let's see here. Someone said Delrin melts. Yeah, any of these things can melt. That's why you use a single flute cutter. Cutting plastics is sketchy. I'm not a big fan of cutting plastics. When do I think I'll do a video release of the first cuts in the Okuma? Hopefully when we can take some. You guys may have seen that I released a video where there was we did a little skim cut on a part and trying to prove out the post. But the coolant, we filled the machine with coolant the other day, and the coolant pumps, for whatever reason, are not, I don't think that they connect. I don't think when they commissioned the machine, they didn't connect the coolant pumps. So I was going to start troubleshooting it myself and checking the contactors and stuff like that. But I figured, I'll just wait. Because like I said, the laser tool setter should be here this week. The X7 that I have set up the way that one is set up, I believe is right around $33,000. Yeah. Well, so Kat's saying, I'm in the market for a CNC, and I'm a member of the SIL Facebook group, and every other post in there is a problem that someone's having. Yeah, because that group is probably there's really two fundamental, there's two sources really of help. Jeff is one of the guys that owns the distribution setup, and so Jeff is not a machinist, but he's super helpful, and he's kind of like the guy. He's the guy that connects you with who you need to talk to. But there's really two main avenues of support. One is the Facebook group. There's a lot of guys that already have them, and they're willing to help. Obviously, that's not ideal. But the actual lead engineer for the company, who I had to deal with when I was doing some calibration, his name's, I don't know what his first name is. We just call him Chen. But he's helped me out a few times. And so, yeah, there's no question that, like I said, you guys already know, I've already said this. I'm going to say it again. I have a deal with SIL. They supported me making some educational videos. I'm not a salesman. I don't care what you buy. I'm not here to convince you. You need to buy what's right for you. But I do think that the X7 is a good, you get a lot of hardware for your money. For the money you spend, what you get, the Schneeberger epoxy granite casting, the linear guides, the ball screws, the control, like it's a lot of capability. By far I honestly think that's a great value compared to, like, let's just say a fully decked out TM0. But the weakness there is that it doesn't have a tremendous amount of support or documentation. I know that they're working on it, but it could be some time. Yeah, so John brings up a good point. He says, don't read anything into that. Any machine that you follow in a group will be posted problems. People don't post their successes, and that's true. That's 100% true. That's why in the beginning of this live video, I talked about the realization that someday I may have to spin wrenches on this machine. That's just all there is to it. If we keep it, either I'll have to do it or I'll have to pay. This machine was like an extra. This is kind of flimsy right here. Not a big fan of that. Got to do something about that. This machine, you can spend like an extra like $5,000 and get a warranty for like 3 or 4 years or 5 years with like parts, labor, everything. It's crazy, super crazy. That just shows you this machine. When you buy an Okuma, like someone just said that John Saunders bought an M660. I don't know if that's true or not, but just to give you guys a little frame of reference, when you buy a Haas, if you want 1 extra year of warranty on a UMC 500, it's $9,000. And I think when I paid for 1 extra year on my VF2, I think it was $6,000. So your first year is free. Your second year is $6,000. This machine, or when I was looking at the M560, it came with 5 years on the control, 3 years on parts, and 1 year on labor on day one for nothing extra. If you just buy the machine with nothing special, you get 5 years on the control, 3 years on parts, 1 year on labor. And that's because Okuma makes their controls, they make their servos, they make a lot of their own stuff. And that's why they're such robust products. When you go into the Okuma group and you see a guy that's running an Okuma that's like 30 years old, it's crazy, you know? And it's not breaking down every other month. Yeah. How many amps am I pulling in the shop right now? I can tell you that this machine requires uh, 50 or 60 amp breaker for 480. It's crazy. This is crazy. I can't believe that this thing, for reference, I was going to just put this on the same circuit the VF2 was on. It was on a 70 amp 208 circuit. And they're like, no, it needs to be a 125 amp 208 circuit. My X7 has a Syntec control. It doesn't have the Siemens or the Mach. Yeah, that's basically what I've heard from a variety of people, that it's just hard to go wrong with Okuma. And so, yeah, I don't know. I don't think there's a perfect. I just don't believe there's a perfect machine. I don't want to sound like a jerk, but there are no perfect machines. There are no perfect machine tool sales companies or service companies. It just doesn't exist, man. Uh, no, this is a really tough situation because nobody can tell you what the right answer is for you but you. You don't really get to test drive these machines. You know, if you want to go buy a new Ferrari, you can test drive it. You can go sit in it, smell the new leather, drive it around, see how much trunk space it has, if it'll fit your golf clubs or your, I don't know, tennis racket. What do guys that drive Ferraris do? You know, I don't know. But that doesn't really work in this instance. You can't just walk up to this machine and just start banging off parts. And they didn't even have one in the showroom. The only reason I had seen one of these in person before, and one of the guys that runs GenuineSob.com, his name's Nick Taliaferro, sent me a bunch of pictures. I've had 2 spine surgeries. I know I've told you guys this before, so I don't want to beat a dead horse, but I've had 2 spine surgeries, an ankle transplant surgery. This is 41 inches tall, and if you look, I'm just about belly to belly with it. And I want you guys to see that literally the front of this plate is probably 8 inches, I don't know, 8 or 9 inches from the front of this. So from here to here is like 8 or 9 inches. So I don't have to lift a 70-pound vise up over a knuckle on a B axis, like on like the MU4000s or the Haas UMCs, to get it into the machine. I can literally just grab it, lean in here, and drop it right here on the platter. And so the downside is that when this thing is all tipped up, your visibility is basically zero, right? So when this thing's tipped up, you have the spindle nose, which is pretty robust, but you guys can't see, but back here, these are linear rails. So this whole head comes up and down. And so you have to have this thing well out past the platter when you have it up at 90 degrees. I have no idea if you can get dual monitors. I didn't even bother asking. I know that while the machine's running, while the machine's running, you can actually go in and, you're obviously, so this is your primary set of keys. This is your secondary set of keys. So you're in auto, MDI, manual, and then this is all your secondary stuff. I won't bore you guys with the details. If you guys want to cover it in another day, we can. But you can get in there and just basically go back. You basically can hit like a home button right here, and it'll take you right back out to the home screen where you can have a bunch of widgets pulled up and stuff like that. It's pretty slick. I'm not a Windows fan by any means, and so I'm a little torn right now because I really want this thing networked because I don't want to have to pull the USB stick in and out of it 1,000 times a day. But I don't like the idea of putting a Windows machine on a network. So I guess it is what it is. Thank you, sir. Appreciate the encouragement. Let's see here. Yeah, the B axis gets past the Y axis travel issues. Yeah, so yeah, I agree. Let's see here. Okuma controllers are built with different colors. Someone says, "How are our suppliers nowadays?" They're starting to. Shipping is slowing way down. Supply for raw materials is slowing down. We've already been warned by all of our vendors, like, hey, there's a storm coming. So I'm not particularly thrilled about it, but it is what it is, man. I'll do whatever I got. It's 10 o'clock at night on a Saturday, and this is where I'm at. Like I don't drink, I don't smoke. I cut metal, dude, and I read books and I cut metal. That's what and I watch YouTube. That's what I do. So. Oh, Craig's on here. Craig Kruger's on here from Kruger Machining, right? Craig, just making sure. So yeah, I was just talking about your YouTube channel a little bit ago. Have I seen that baby meal from Bantam? I have not. John says, in this day and age, the best customer support exists within the community with many machines. To give you an example, the best customer support that I've seen in all my years is for the Mach 3 on CNC Zone. Yeah, there's no question that at Saturday night, right now, if I was in a jam or had an alarm that I couldn't solve, first of all, this thing comes with a gigantic pile of manuals. I pulled them all into my iPad and I have them on iBooks, and I could just search through them real quick. I could do, basically like a control find. So I can search through them that way. You're more likely to get someone to respond to your issue. In general, I'm pretty sure that Gossiger told me they have 24-hour support, but in general, I think a lot of times, like I know Haas didn't have that. So if I had a Haas issue, it wasn't uncommon for me to post up a quick question while I was here at the machine and see 2 or 3 guys from America and a few other guys from around the world in different time zones respond very quickly. So I don't know if it's okay for a machine tool manufacturer to rely solely on their Facebook community or their social media community like CNC Zone or Facebook, but there's no doubt that it is a valuable resource for sure. 100% for sure. Dan, I apologize. I do not know. I do not know how many M codes are available on this machine. Books, metal, and YouTube, not a bad selection. I do what I can. So, yeah, I'm excited. We got the post, I believe, sorted out, and we'll see how it goes here shortly. We'll start making chips. When I start making chips, you guys know I'll make some content for you guys. So. Oh, somebody asked earlier about classes. Let me see if I can find that real quick. Somebody asked. Yes, we are going to do. Yeah, Britt, are you still doing your training classes? If so, you'll be doing any training on the 5th. I'm a little nervous about dropping the cash without having any hands-on first. Brett, shoot me an email if that's something you're interested in. I'm sure we can make that happen. it's tough. I had like 70 guys, just short of 70. I think it was like 66 or 67 that reached out that were interested in the training class and were like keeping in communication with me. One of the challenges that I found is that I called a few of them and I just said, "Hey, there's widely different skill sets, like widely, vastly different." And so I'm not sure if we need to group this together. I'm pretty lucky. My wife has a degree in medicine. Her sister has a doctorate, and she's an educator down at here in California at one of the universities. So they both told me they would help me kind of create basically a syllabus and like a workflow to make sure. The big issue is we want to make sure that anybody that walks through these doors and writes a check to learn something, we want to make sure that when they leave, they got exactly, at the very least, they got exactly what they were promised, and hopefully much, much more. But the last thing you want is someone coming in here. We teach you the fundamentals of work offsets, tool offsets, reading some of the basics of G code, creating good habits with single blocking through your programs, and then you go home and you don't use it and you lose it all, and it's just a big waste. That's the last. That would not be a win. So we use Fusion 360 with NC Simul for verification. So I'm happy with that for now. So. All right, guys. Well, it's getting pretty late. Am I a Fusion 360 guy? I'm not an anything guy. I don't. We have two Fusion 360 licenses, one with the machining extension. We have two SolidWorks licenses. With one, we have HSM Works, and that's up to date and on subscription or whatever. Everything, the SolidWorks and the HSM Works. But I just find that Fusion is faster. And when we work on a project as a team, it's way faster, super faster, super faster. Yeah, I'm going to trademark that. Super faster. All right, well, you guys, it's 5 after 6, 10:06. I appreciate you guys hanging out. If you guys enjoyed this live video, do me a favor, click the thumbs up button just to show me that you guys enjoyed hanging out here with me for a little bit. It means a lot to me that you're here. I don't know why you're hanging out watching a short, chubby nerd, talk about CNC machining on a Saturday night. I'm sure there are plenty of better things to do, but either way, I'm glad you're here. And does NC Simul give you a warranty if it messes up? I have no idea. I have no idea. I know, Jim. I agree. Takes one to know one. Oh, it's morning somewhere. SR Products. They're talking about the Mortal Kombat shirt. You know what? Why we're here? Hold on one second. I want to show you guys something real quick before I let you go. Since the boys at SR Products just popped up, I want to show you something. They mailed me this the other day, and I showed it off a little bit, but he sent me an email and he asked me if I would. Actually, it's funny. I don't know if you guys can see this, but this is our tool tray that they sent us. I don't even think I did a video on this. I just never showed it off. But let's see if it shows up. But anyways, what I'm going to do is I'm going to grab the vise with the. I want to show you guys this double vise converter thing because I don't think it kind of got the. I saw a lot of guys kind of hating on it, and I'm just a fan. Is the truth. I'm a fan of this thing. So I just want to show you guys real quick up close. Since you're here hanging out anyways, since we already agreed we're all CNC machining nerds. So here's what this thing is. This thing basically, let me get the speed handle. What this is, you have a lot of parts where you don't need a huge amount of travel. You can see right here that we could easily have a part that's, a couple inches in some soft jaws, or we could have one here, and so on and so forth. This vise is about a $500-600 vise, maybe a little bit more. A dedicated dual station vise is like $2,000. It's no joke. And seeing that they could increase work holding density, the guys over at SR, which by the way, this is a quality product. These guys are like an aerospace shop. They came up with this thing called the double vise converter, and it takes your standard 6-inch vise. Now it has to be a 6-inch vise that opens quite wide. Like the really small machinist vise probably won't work. This one has 9 inches of travel. But what you can do is you can actually put this thing in here. This floats a little bit, so that's an issue. That has to be accounted for. They say that it has less than 5/10 of jaw lift right here, and so somebody was kind of bashing on it in one of the videos that I did, and the guys from SR sent me an email and said, "Please do a video with an indicator on it." So there's nothing for me. There's nothing quite like seeing the confidence that people have when they know they've made a solid product. So I just thought I'd show you guys this. It's relatively cheap, $350 ish, 300 mid to high 300s ish, but it converts your vise into a double station vise. So if you have two or three of these on the table, I mean, think about it. Buying three $2,000 vices would be $6,000, or buying three of these for $1,000. So 1,000 versus 6,000 for a dramatic increase in work holding. So I just wanted to show you guys this. When people come up with cool stuff, I'm a fan. It's just all there is to it. It's yeah. I mean, so a couple things for the record. If you had a dual station and it was holding a really big part and that wouldn't do it, then you can't do it. But it's one of those tools that if it will work, man, it's a winner. And if it won't, then I guess you're gonna have to write a big bet check. Cool. All right, guys. Well, that's that. Appreciate you guys coming to hang out with me. I'll do my very best to get on here a little bit more frequently this week. When we get the laser tool setter installed, we get everything in here. The coolant pumps are running. I'm going to touch off a bunch of tools. I'm going to run through the post one step at a time just to make sure that the post is 100% perfect. And once it is, we'll upload some code and start making chips. Thanks for hanging out with me today, and I'm going to shut this thing down right now. Bye-bye.